Hello everyone, I'm back for another update. I know it's been a while. I'm back at the summit of Middle Mountain, and the reason why I like coming up here so much, for one, there's no trails. For two, I have it to myself 99.9% of the time. I've never run into anybody up here. And number three, it's a designated national wilderness area. I got me a new pair of trekking poles. I only paid $12.50 for them at a thrift store. And I also got a sleeping bag that actually you can plug into a charging bank and have a heated sleeping bag. In case I do decide to go on a through hike. So I am starting down off the mountain now. Leaves are not out yet, but they normally aren't until around last week of April anyway. A couple of trees starting to pop out a bit because it's been warm up until last couple of days. And last night we had a hard frost. We got down to 20s here this morning. And the cold pattern that I predicted did verify for the northern tier of the U.S. especially. It didn't come as far south as I thought, but places with northern tier such as Maine, up in the Dakotas, northern Minnesota, UP of Michigan has really gotten blasted the last few weeks. Winter weather. The reason why the cold air did not come further south is because the MJO had a lot of convection in phase 5 zone recently, and that kind of pushed a ridge up against the cold air and created a battle zone for the center of the U.S. But the MJO is also showing convection in some of the colder phases. That's balancing out. And right now it's trying to go into phase 7. A lot in phase 1 as well. Amazon has a lot of convection. So the reason why we're getting warm pattern out west is there's a phase 3 influence in the MJO, and there's a huge trough pushing down over the eastern Pacific. A huge push of Arctic air is pushing south into the eastern Pacific. What that's going to do is push a ridge up over the western U.S. and bring some very warm temperatures, like places such as Arizona, where they may be breaking record highs, not due to global warming, but more due to the meridional flow of the jet stream, where we got a huge dip in the jet stream over the Pacific, eastern Pacific. It's going to push up a huge ridge over the western U.S. and a trough over the northeastern U.S. and the western Atlantic. And there's another huge trough over the far eastern Atlantic, knocking on the door of the Canary Islands. So we got a pretty meridional flow in the jet stream right now, developing. And as far as climate is concerned, I had been talking about interglacial and ice ages and the transition periods. And I was recently on a Zoom call with Jennifer Morency and several others talking about she's trying to develop a new theory on climate change. She feels that we need a new theory on climate change. We got to stop fighting the current consensus and develop a new one in place of it instead. I agree with her 100% on that, and I even got a chance on the Zoom call to express what I feel should be developed as a new theory for climate change, and what I feel. I mean, this is an expert climate scientist I was speaking with in Australia, and she gave me a chance to express my view on what I feel should be the new theory, along with a couple of other people. 2 or 3 others were on the call, and what I said was it's the sun and variations in solar output. As I've been talking about on my videos, there have been huge variations in solar output over the decades and decades to decades, from century to century, millennia to millennia. There have been huge variations in solar output. I feel it is the sun and changes in the sun that cause ice ages on Earth and interglaciers. Now coming down off Middle Mountain, just similar to where I was on my last video, but I just love coming up here because it is a wilderness area. And I can just cross it to get here over the creek behind my house. If I can cross that, I have access to this whole thing. So back to what I was talking about. The sun. I brought out that the sun should be the primary driver of climate change to the group. And she also feels, and I'm in full agreement, that the CO2 increase in the atmosphere in recent decades, since 1850, has not been caused by man, but has been caused more by natural causes. She feels that, and I agree with her, that CO2 increase is mostly from the oceans. When the oceans get warmer, they give up more CO2 into the atmosphere. When the oceans get cooler, they absorb it, and CO2 levels in the atmosphere go down. And so we're going to be having another Zoom call on April 25th to talk about Mount Pinatubo and how it caused the increased carbon dioxide in the atmosphere to temporarily slow down. And the consensus there, or what we're going to be talking about probably, is because Mount Pinatubo eruption caused climate to cool temporarily, which it did, the carbon dioxide increase in the atmosphere during that period around 1992 slowed. I mean, the increase didn't stop, but it did slow down for a time. It coincided with that eruption in 1991. I believe it erupted in June 1991. And I remember the climatic effects of that eruption. The blizzard of 93, I feel, was a result of the climate impacts of that eruption. And the Pinatubo summer in 1992, they called it, where we had a very dull, cloudy, cool, wet summer that year. Even in North Carolina, where I was living, where 60 inches of snow in May fell in the mountains of North Carolina that year. And I still remember I was in Asheville and it was raining and 38 degrees, and I remember saying to myself, I'm wondering if they're getting snow up in the mountains, and sure enough, the Blue Ridge Parkway was shut down because of 60 inches of snow. This was in May of 1992. And I feel that that was a result of the Pinatubo eruption, or a byproduct of the effects of it. So that eruption cooled the climate, but it was a drop in the bucket compared to what past eruptions have done, which are much larger, much bigger. And we have a number of volcanoes rumbling that have been threatening an eruption lately. And also that year, the Alaskan volcano, which is rumbling now, erupted in 1992 3 different times, and that contributed even more to the dull summer that we had that year. Cloudy, wet, cool, because that Alaskan volcano also erupted and added even more dust to the atmosphere. Yeah, getting back into now, there are 3 or 4 huge volcanoes that are rumbling right now, threatening to erupt. So far, nothing's come of it, but we got one in Greece, we got one in Italy, we got that Alaskan volcano which has been rumbling, we got Iceland, we got Ethiopia, so we got 5 different spots, at least a half a dozen perhaps, volcanoes that are threatening to erupt right now. So time will tell on that. The Solar Cycle 25, the official count today was 120 sunspots, which puts it in the league with 24. That's where we were at Cycle 24. It's been 24 was the weakest cycle in over 100 years. There's some that feel that it's a 100-year cycle and 24 was the low point and we're going to go up from here, but people don't understand the longer term cycles of the sun. I mean, I've heard some solar physicists, scientists say that the sun is going to go to sleep very soon as part of a much longer cycle, which would catapult us into an ice age situation within a few decades. Of course, the glaciers would take some time to form and grow, but the climate would turn into an ice age type of climate, perhaps within a very short period of time, relatively speaking, if that were to occur. And that is what we really must prepare for, because our interglacial is on borrowed time. And I'm pretty sure there is some sort of cycle connected to it. Some say it's the Milankovitch cycles. That might be a catalyst. But I feel it's ultimately changes in the solar output that is the control knob for climate. And yes, there is such a thing as climate change, but it's a natural process, and man has very little to do with it. Man's activities, other than a heat island effect, maybe that's about the most that mankind will do. And the reason why I feel it's unlikely we're going to see warmer temperatures is because, yeah, we're on borrowed time with this interglacial we're in. We're on borrowed time. It's due to end any time. And the thing is, with the sun, if the sun does go to sleep on us, it's not going to blink out totally, but go to sleep in the sense that it will cause global temperatures to drop into ice age regime. And the question is the sun, we have enjoyed in recent decades a very, very stable output for the sun compared to the overall record, which is why our climate has been very reliable and stable. But for most of the sun's history, there have been much more variations in its output. The evidence is very strong that when we came out of the ice age, the sun got very active, and that caused a sudden jump in global temperatures. It started to melt the ice sheets. Of course, the ice sheets didn't instantly melt, but over centuries, the ice retreated back. And then we had the Younger Dryas event of some sort of an impact, they think it was, that hit the ice sheet fragments, and that plunged us back temporarily because so much meltwater was dumped to the oceans that it screwed up the circulation patterns of the ocean. The climate, despite the sun being more active, temporarily went back to ice age conditions for a while. Because of all the mayhem that came with that. And then we came right out of that. Once the effects of that wore off, we came right out of that, and the climate went into an optimum, they call it, where it was considerably warmer than today. Sea levels rose as the glaciers melted off to higher levels than, and nobody talks about it, but I feel that the Arctic sea ice disappeared during the climate optimum. It melted away completely, leaving open water over the Arctic regions. The Arctic Ocean was open water, or became open water during that period, and did not refreeze back completely until the Little Ice Age. I feel there was open water up there from the climate optimum period, which was 5,000-6,000 years ago, to present. Most of that, the Arctic Ocean, at least in the center, was probably open water until the Little Ice Age. Now, during colder periods, I'm sure that the waters around Canada, the islands, and Bering Strait area, Russian coastline, probably did freeze during the winter, but melted back in the summer during colder periods because the center of the Arctic Ocean is very deep water. It would take a lot of cold to freeze that. I feel that the whole entire Arctic Ocean did not freeze over until the Little Ice Age. Again, in the 1300s. Now, I'm not sure if it froze during the first phase or the second, because it came in two phases. We had a Little Ice Age, 1300s, where there was a solar minimum, and then we kind of came out of it for a little while, and then went back in during the 1600s, and but the legends of the Arctic being warm with open water, there's truth to those legends. And that's what the people, all these Arctic explorers in the 1800s, are looking for, or hoping would be, that the legends would be true, but all they found was endless ice. So, what does that imply for today? Well, the Arctic sea ice has been stable for the last 20 years. They're at its lower levels, but it's stabilized. Glaciers are starting to show signs of an advance again. I said in my previous video that 2022, I feel, was the turning point for glaciers, and that a potential glacial advance long term began in 2022. We're going to see it manifest more in the coming decades, especially if the sun goes into a slumber, a longer term slumber. I can't say for sure that's going to happen. I mean, some scientists are predicting that it's going to get more, the sun's going to get more active again. We're not going into a minimum. There are some that say Zarkova was totally wrong with her forecast. I don't feel she was completely wrong. The cycle is only slightly stronger than 24 was overall. And I feel also that they're hyping up the sunspot counts. Like today, there were only 7 active regions. They said there's 120 sunspots. And I could see if the regions were huge groups of sunspots, there were only 2 larger sunspots on the disk right now. The rest of them were pinpricks. I don't see how they came up with 120 on the count. I feel the count is more like perhaps 90 maybe. But I'm not the one counting sunspots, they are. But if the solar cycle 26 is the last solar cycle, and that's it, the sun goes into slumber, everybody in the earth is going to be caught off guard, not unprepared, or most people are going to be totally unprepared for what's going to come, and lots of humanity is probably not going to survive if that happens. And I can't even count myself out of the equation. I mean, very few people are totally self-sufficient or can just up and move south at the drop of a hat, but that's basically what it will come down to. Or if you're in the southern hemisphere, move north. One of the remarks that Jennifer Moorhense asked me was, well, if northern hemisphere sea ice is stabilized, why is Antarctica ice so low the last couple of years? I told her, well, I said, you got to think about it. The Antarctica is covered by a continent with pretty much permanent ice cap on it. The Arctic Ocean is water. You just have Greenland, that's it. Maybe parts of Baffin Island have permanent ice, but most of that area around the North Pole is water. It's seawater, frozen. Antarctica, on the other hand, is ice. Ice-covered continent, meaning that the fluctuations in Antarctica for sea ice are not the same factors that influence that as the Arctic Ocean does. As I told her, that warmer ocean currents is what caused the decline in sea ice from the preceding active periods of the sun. That's what I brought out at the Zoom meeting. And then that's what triggered her question, well, what about Antarctica? I said, well, Antarctica reacts differently to climate changes than the North Pole does because it's a different set of factors. You got a landmass there, a huge landmass over the pole or partially over the pole. And so it doesn't mean as much climate-wise if there's some years where almost all the ice melts from around the continent of Antarctica in the summer. So it's really, even if the ice completely melted around the continent of Antarctica, it would not really influence climate as much as if all the sea ice melted off the Arctic. And why, I told her I don't totally understand why Antarctica, the only thing I could tell her was the Antarctica seems to do the opposite of what the Arctic does. The Arctic loses ice, Antarctica gains. I brought out that in 2014, the Arctic Antarctica had record levels of sea ice around it. And then now, just 11 years later, they claim there's way below average sea ice now. I brought out that, Antarctica southern hemisphere reacts differently around Antarctica to climate changes that we don't fully understand. And that's what I brought out, and the answer was acceptable to her. But she is a climate expert. She's in Australia. And yeah, I'm looking forward to the next Zoom call. And I will relate the results of that discussion on Mount Pinatubo. And again, discussion is going to cover how that volcanic eruption affected the CO2 increase in the atmosphere. It's going to be very interesting. So that's going to be it for this video. I got to get down off this mountain, as I got things I got to do when I get back home. I'll be back soon.